Okay, let's continue learn PCB PDN analysis by CST. This time we will run PDN analysis with CST. We only consider when we fail the power line. Okay, this is when we fail. What we will consider pins. In this time, we will consider pins in U8 and pins in U1. Yeah, this is U1, this is U8. For this PCB board, all the net class has finished the auto tagging and all the components property has been finished. Before we run the PDN analysis, there is one thing I want to share. I give an example with capacitor. In this capacitor, we can see except for capacitance value, there is another two values. We called ESR and ESL. ESR and ESL is parasitic resistance and parasitic inductance. If we don't set up ESR and ESL, then the capacitor is an ideal capacitor. But to keep realistic simulation, we should give an value, ESR value and ESL value. Then we can begin the first simulation. We click PI analysis. I have chosen the pins connect one-way fail pins in U1 and U8. I set up the minimum frequency and the maximum frequency. The default option is start local simulation run. But because we will compare different projects result, so here I click create simulation projects. I select PCBS. We can give a name by ourselves, or we can switch on automatic labeling. Then we can click create SP. This is our first simulation result. This is a first simulation project. We can check the 1D plot result. This is the pins from U1 PDN impedance. There are the main resonance frequency point is one is in almost 171 megahertz. Another frequency resonance frequency point is 995 megahertz. We can also check U8. This is all pins from U8 PDN impedance. For this example, we are only consider two pins. One is U8 A2, another is U8 M9. We can see for these two pins, there are three resonance frequency point. Let me mark the resonance frequency point. There are main three resonance frequency point. One is 168, the second one is 343, the third one is 431 megahertz. So next one, I will show you how to lower or how to eliminate this resonance frequency point. If we check the two pins in the PCB layout, we can see for U8A2, it connected to capacitor C70, C73. For M9, it connected to capacitor C75, C76. So next I will show the optimized result through change the four capacitors capacitance value. For U8A2, it connects C70, C73. For M9, it connects C75 and C76. I will change we can change the capacitance to optimize the PDN analysis result. Actually, this value is optimized value. We can see the optimized result. I can copy this value to the first CST project. We can see the red curve is optimized result for the U8A2 pins PDN impedance. These two resonance frequency point has been eliminated. And for the U8M9 PDN impedance result, the green curve is optimized result. We can see this main frequency resonance frequency point also has been eliminated. If we compare the optimized result, we can find the U8A2 result is lower. Impedance result is lower than the U8M9 impedance result. Actually, we can explain this phenomenon. The reason is because, okay, we go back this PCB layout. The reason is for U8A2, it connects the two capacitors directly. You see, it connects the two capacitor directly. But for the M9, it connects the two capacitors through a wire. Yeah, you can see the M9 didn't connect the two capacitors directly. It's through a wire connect the two capacitors. That's the reason. The wire will lead to a higher PDN impedance. Okay, that's the reason why M9 impedance result is bigger than the A2 impedance result. Next, I will show you the third CST project. The third CST project. In the third CST project, we optimize or we use the optimized value for all capacitor. And I have simulated the CST result. This time I only calculate PDN impedance result of pins from U1. We can see for the new result, when the frequency is lower, almost no resonance frequency. There is only one resonance frequency. It is almost 992. Actually, except for the 1D plot, we can check the 2D or 3D plot in CST. How to check? We just click PI analysis. We just go to special, click spatial impedance plots. The default setting is switch off generate plots. Here, if we switch on generate plots, then we can check the 2D, 3D result. We can choose a reference layer. Here I choose GND, second, the reference layer. We can change some value of the option. About what's the meaning of the option, we can check on the help. We can check one result. about the 2D 3D result. I only show when we fail the net. This is a PDN distribution result. Through this result, we can find the hotspot. We can see there are the main hotspot is in this area, and this area. So if we want to optimize this result, we can place some decoupling capacitor in this area. So the last CST projector I want to show you is you will see I put some capacitor in this area and this area, also this area. We can see the result directly. From this result, we can find for this area with big impedance result has been optimized with some decoupling capacitor.